So I'm going to start by demoing one of the first tools that we provide to energy companies in order for you to build a pipeline of projects. So you know how much money that needs to be invested in order to energize remote communities. So this is super cool. What we start with is basically some geo-coordinates of an area that you need mapped out. Once we've got those geo-coordinates, we have an AI algorithm that basically identifies rooftops. And once those rooftops are identified, we have another set of algorithms which takes an average load. So let's say 600 watt hours per day is how much you think these households will use on average. And then our algorithm automatically calculates the least cost electrification mode. So here you can see this is a site in Togo. And the orange points are systems that should be installed standalone because the distance from the closest household is quite far. The cable costs would be quite costly to interconnect them. But this cluster here, 6 households, it's recommended to interconnect them into a mesh grid using our Okra technology. And so, bringing all of that together, we can rapidly size a pipeline for you. So if we look over here at the summary numbers, we've got 526 households that have been mapped. And the least cost electrification tool estimates that for 600 watt hours per day average load, there's $400,000 of CapEx investment that's required using the Okra mesh grid architecture. Using a traditional centralized powerhouse to serve these 526 households would cost over $1 million. So that's more than double the cost. And obviously, one of the main reasons why costs are reduced is that under the mesh grid architecture, you're not drawing expensive transmission and distribution all the way from the first house to the last. You're just connecting up the mesh networks. That makes sense. So that's Spekboom, our least cost electrification tool.